Hi, it's Jason Gorman from Codemanship with the first of 6 special screencasts to celebrate 6 years of Codemanship. The first screencast I'm going to do follows on from a blog post that I published recently. Let's just go back up to the title there, the Big Giant Object-Oriented Analysis and Design blog post. So I highly recommend that you read this blog post first and then take a look at the rest of this video. But just to skip to kind of the end of the blog post, it's all about doing OO analysis and design in a test-driven, agile way. And at the end of it, we come up with a design that we believe will pass an acceptance test for donating a DVD title to a community video library. So our design is expressed using a very simple modeling tool called Class Responsibility Collaboration Cards, or CRC cards. Very, very straightforward. You take an index card or a post-it note, you write the name of the class at the top of the card. Down the left-hand side, you list its responsibilities. What does it know and what work does it do? And then down on the right-hand side, you list any classes that it collaborates with. In other words, who does it tell to do work? So in order to pass the acceptance test, each object performs a specific part of the work, achieves a specific outcome for the user, and then it tells other objects, potentially, to do their part of the job, so that they coordinate overall the effort of passing the acceptance test. So we believe we have a working design here, which we're going to implement from the outside in. So we're going to start with the outermost object, the one that's closest to the user, if you like, which in this case is library. And we know this because if we look at the cards, library has no other objects telling it to do stuff. So it must be at the outermost object, the one that's closest to the user, the entry point to this design, if you like. Member, on the other hand, doesn't tell anybody to do anything. And therefore we can safely assume that it is the innermost object in our design. It's at the bottom of the call stack, if you like. Email alert, there's a question mark there because I think there's probably a whole can of worms behind this email alert interface that I don't want to think about right now. What I want to do is wire this thing together end to end, so we got most of the work done, using a placeholder for email alert. So we're going to fake email alert until we make it, and then once we've got that placeholder in there, wired in with the other collaborators, we can think about what's happening behind its interface at a later point. So we're deferring the design to the last responsible moment as to how we're going to send email alerts. Okay, so that's our design. We're going to test drive it, starting with an implementation of library. Now, to wire a design together end to end, we can mix and match 2 styles of unit testing. So if we're testing responsibilities, that is, if we're testing that objects do the work that they're supposed to do, we can rely on the sort of traditional style of unit testing where we make assertions about what should be true, make assertions about the effect, if you like, of a particular action on an object's state. And you're probably very familiar with that style of testing. If we want to write failing tests, or tests that fail because of a collaboration, then we can use mock objects to write those kind of tests. So you can see there's 2 styles of testing that we're going to use. One style helps us to test drive the work that objects do, their responsibilities, and the other style of testing allows us to test drive the collaborations between the objects, so we can wire them together in a test-driven way, by writing failing tests. And that's actually why mock object frameworks were invented in the first place. So let's do some of this implementation to give you a flavor. I'm working in Java, and why not? You know, I'm an old guy, so I might as well use an old language. Right, we're going to write a unit test fixture for the library class, and a logical name for it might be something like library tests. So it's obvious what we're testing. Okay, the first thing I'm going to focus on in my test is its responsibilities, the work that library does. The first piece of work it does, according to my design, is it adds donated titles. Title added to, well, it's the list of all titles. So it's the main list of titles in the library. Okay, and I'm going to start by writing the test assertion first. and work backwards from there. It's a good habit to get into this. Actually, that's the wrong kind of assertion. So I'm going to ask, if once a title has been donated by a particular member, I'm going to ask whether it's in the library. And I'm going to do this in a brute force way. Fans of encapsulation and tell don't ask, look away now. Okay, so let's imagine we've got a library. Immediately we've got a red squiggly line that says, well, there's no such thing as library. Well, there is now. Golden rule of TDD, we don't declare a line of source code until we've got a broken or failing test that requires it. And it's a good habit to get into to have one thing broken at a time. So there's our titles list, which requires a method on title, which again it will try to make Boolean. I don't want that to be Boolean because I'm not done yet. This is a list of title. And well, let's do it now. Again, that's part of the source code. And let's import list. Okay, and what we're actually asking is whether or not that list contains the title that we're donating. So let's declare that as a local variable. So you can see I'm working backwards from the assertion. And we now need to start initializing some of these variables. So let's make library a new library. Now, I could just initialize this to a new title. That will be simple enough. But as you'll see, there's a method to this madness, so please bear with me. What I'm actually going to do is I'm going to create a mock title. So it's not a real title that we're adding to the collection. It doesn't matter that it's not a real title because we're not actually interacting with it. And it's very important to remember that even though I'm using a mock, this test is not about the interaction between library and title. I'm just using the mock as a placeholder for a title. So let's import the method we need there. Thank you very much. Now when I run this test, let's just actually do the donation bit. So what we're going to do, this is the action that we're testing. We're going to donate the title, but we also need to say who's donating it. So let's say that we have a member that we want to associate with that particular donation. It's part of our requirement. It's very important that when you write tests, even if, no thank you, even if objects are not necessarily going to be used in the implementation, it's important to write test code that is valid in the light of the requirements. So member has to be there, although at this point in time we're not doing anything with member. It's not valid to donate a title without specifying who's donated it. Right. So what I've got now, hopefully, and again I'm going to mock the member. And the method to that madness hopefully will become clear in a wee while. So we got our library, we donate a mock title on behalf of a mock member, and then we write an assertion to check whether or not that title is in the list of all titles for the library once we've donated it. If I run this now, let's just run this one test. Come on. Yep. And we got a null pointer exception. So the assertion's not failing. We're not actually getting as far as evaluating the assertion. I want to see this test fail for valid reasons, which means I really want to see the assertion fail. So I'm just going to do the bare minimum here to get this failing for a meaningful reason. Okay, so if I run this now, the assertion should fail, okay, because it's not actually in the list. Obviously it's not in the list. And the simplest thing I can do to get this test to pass, well, let's start by creating a local variable, and let's call it titles. Okay, and let's make that a field because we want to reference it in a different method. So it needs to be a field really. And let's not initialize it here. Let's make sure that it's already initialized when we donate. like that. So when we actually donate the title, and all we're really doing is this. Symbols. Now when we run this test, it passes, which gives me permission now to do a little bit of cleaning up. Let's just check that that's okay. And let's go back into library tests. I don't think there's much here that I can really clean up. That's about as simple as I can make it at the moment. Now that I've got that behavior working, it's fairly trivial behavior, so no need to triangulate around it. And if you're not sure what triangulate means, I highly recommend checking out Kent Beck's book, Test-Driven Development by Example. But this is an obvious implementation, so I've not bothered with triangulation. It has left us with a bit of nastiness here, a bit of what we might call a message chain. So what I'm going to do is I'm going to refactor to get rid of this message chain so that we're going to encapsulate the business of finding out whether or not the titles collection contains a title behind the library interface to make it a little cleaner and to reduce the amount of knowledge that client code would have to have about how library works internally. So let's extract a method and let's call it contains, and this is going to be private. That's fine for now. So we've got the library and the title as parameters. That should work. Let's make it public because we're going to move it to library eventually. Okay, let's just check that hasn't broken anything. Looking good. So what I'm going to do is I'm going to move this to library, like so. So we discovered a little bit about what the library interface needs. And we're going to move on now. I'm happy with that. We're going to move on to the next bit of work that library does. So as well as adding a donated DVD title to the list of all titles in the library, it also has to maintain a list of titles that have been added since the last time we sent a members newsletter. So on a regular basis, we'll send out a newsletter to all members that lists all the titles that were added since the last time they got a newsletter. So we need to maintain this list of new titles. I'm going to give myself permission to do something that I wouldn't normally allow people to do, but for the sake of brevity, let's just do this, because the tests, as you'll see, are very similar kind of, except this time we're going to change the collection that we look at. So we're not looking in the list of all titles, we're just looking in the list of new titles. Let's create that method. A little bit of weirdness going on with Mockito there. That's a list of title, thank you. And as before, we don't want this to fail because this is returning null. So we do the minimum of amount. I'm just going to skip ahead because we kind of know what's going to happen here and it is trivial. Titles, and let's initialize it here. New titles, new array list. There we go. So if we return this collection, at the moment we're not doing anything to it, so the test will fail, but it'll fail for, oops. What are you complaining about now? Ah, yes, the test method names are identical. That's silly me. Donated title added to list of new titles. Silly me, silly Jason. There we go. Okay, now I'm passing this test. A bit of cleanup to happen in here. Oops, no, we're not gonna clean up yet. Yes, no cleaning up yet, Jason. You haven't got permission to do that because the test is actually failing. I got a bit of green blindness there. I didn't notice that it was only running the one test. I actually need to run both tests. So when I run both tests, I noticed that there's a red bar. So I got a bit of green blindness there. The green mist overcame me, and I thought I had both my tests passing and was safe to refactor. I forgot that I hadn't actually written the code to pass the second test. To pass the second test, all we have to do, again, it's trivial, so we'll just do it. We won't triangulate it. No need to take baby steps because it is a baby step. And there we go. Right, now we have permission to start doing a little bit of cleaning up. And most importantly, these tests are almost identical. Let's start with this little thing here. So let's extract a method, contains new title, contains new will do. Okay, that should still work. And let's move this again to library. Hopefully it all makes sense. So now we've got two tests that are almost identical apart from the assertions. And this gives me a strong indication that maybe this code here should be part of a shared setup or some method that does the work. There's different ways we could do this. Now what I'm going to do is I'm actually going to extract it all into a method and just big return value, because let's make library a field. Okay, try again. Okay, so let's just call this donate title to library. It's going to be our helper method for the test. Okay. And once I've done that, I can then substitute here the same code. No. That's wrong. I do apologise. You can tell I've rehearsed this, can't you? Let's move those around and just check that we haven't broken anything. Good. Now let's substitute. Now you're probably still wondering, why has he used mocks? All will be revealed. Delete title to library. A small I. That might help. Okay. So we're removing quite a lot of duplication there. There's still some left, but we can focus on that in a bit if we need to. Now, because this always happens at the beginning, we could make it a setup method. The problem I have with that is it's not just setup. The actual action we're testing is in there too. And I do sometimes like to leave myself the ability to vary the setup from test to test. So a setup method is code that will always be run before every single test in this fixture. And I'm not entirely convinced that in this case, let's make that private. I'm not entirely convinced that in this case we need to do that. Or we can get away with doing that. So we might learn at the end that, yeah, all these tests are identical apart from the assertions. But for now, let's just keep it as it is and keep it nice and readable. So those are the two pieces of work that library does. Now we've got to focus on the collaborations it has. So it tells other objects to do work. First of all, it tells the title to register a copy against itself. Let's call this the default copy. Okay. And this is a different style of test. We're not writing assertions now. We're interested in the interactions. So we're going to test using our mock, in this case a mock title, that the register copy method that we just imagined in my head is invoked. So let's create the variable title, and here's the bit that hopefully will explain why I used equal to library. And we need to obviously import .mockito.verify. Okay. Now we need to declare this register copy method. And we have now a test that will fail because this interaction isn't taking place. There we go. Register copy was wanted but not invoked. So passing this test, again, easy. All we need to do is wire them together in the donate method. So and bingo. test passed. Okay, and the one last piece of business that we need to think about is that library tells the member to award him or herself priority points, in this case 10. Okay, a similar pattern as before. We're verifying that an interaction has taken place, this time on member, and let me just quickly make it possible to ask that question. And let's call it award priority points. 10. So how many we want to go for? So let's declare that method. Points. Now, in this test, we don't care whether a member actually does award himself priority points because it's not actually important. Run that test, it fails. Null instead of mock exception. Aha. Now this is interesting. And that is interesting. Null instead of mock. Being a div here. This is a strong indication that it probably does need to be a setup method. To library. That's what went wrong there. I didn't invoke the method. Now we're getting wanted but not invoked. So we can clean this up later. Let's go back into library and wire that last collaboration up. Award priority. Butterfingers today. And it's library that knows that it's 10 points. Priority points. And this should make the whole thing work as intended. Lovely. So it does two pieces of work and then it collaborates with two other objects. And that is the implementation of that CRC card, that simple model that we had for library. Let's just go back and clean up our tests a bit. If I make title a field as well, and then what I can do, get rid of that, make that void. Bugger. Oh yeah, that's why. And then remove these. Like so. And make this a setup method. Okay, so there we have 4 tests, each of which are asking different kinds of questions. 2 of the questions are about the work that library does, and 2 of the questions are about the interaction that library has with other objects. Now that we've got library working to our satisfaction and we've put in those placeholders in for the objects it collaborates with, we can move on to writing tests for an implementation of title and an implementation of member, and start working our way down through the call stack like that. So let's move on to title. So let's create a test fixture for title. Let's call it title test because we're very imaginative. And again, there is work that title does, and then there are collaborations that title has. So potentially two different kinds of tests. If we go back to our design and look at the work that title does, if we take a look there, title registers the rental copy. So we've kind of hooked in, we've got the queue for that. Now we need to implement it, okay, in a test-driven way. So registers rental copy. and we're back to traditional assertions. In this case, it's the count of rental copies. So title get rental copy count. And what we're saying is that should be equal to 1 once we're finished. So let's create a local variable title. And let's declare that method get rental copy count, which should return an integer, not an object. Let's make it 0 for now. So the test will fail. And we've initialized title. Okay. Now, at this point, what we're saying is that title sends an email alert. So title has a collaborator. If we look in our design, it collaborates with email alert, and I think it should probably be born with the object that sends email alerts. So we're going to hook in a mock at this point just as a placeholder. Let's call it the email alert. And now, like I said, we're not going to worry about how email alert works at the moment. We're just going to create a placeholder for it in our source code so that we can wire it in and then worry about how it actually works later. Let's create that constructor. Yep. And we're going to initialize this. I'm going to use, again, method to the madness. I'm going to use a mock email alert. Even though this test isn't about the interaction with email alert, I'm just using the mock as a simple placeholder. So let's import that from Mockito, that static mock method. Okay. So far, so good. And what we're saying is when we tell title to register a copy, and the way it works is just one at a time, it should increase the rental copy count. At this point, we don't care about whether it talks to email alert, but we need it in there as a placeholder, as a test double. Okay, now when I run this test, let's see what happens. Expected 1 but was 0. So that's a test failing for the right reasons. That is, the assertion is failing. Now, again here, if we look at the implementation of title, we could triangulate around this behavior, but I think it's actually pretty trivial. So this may well be a case of an obvious implementation. So let's actually have a copy count. But let's initialize it to 0 here. And when we register the copy, let's count plus, and we're going to return the copy count. Now I think that's a trivial implementation. I wouldn't necessarily triangulate on it. If it was something less trivial than that, I might well do. Permission to clean up, sir. Let's do that. And there you go, a very simple, trivial piece of behavior. And let's go back to our test. Do we need to clean that up? I don't think we do. But as we're about to get a big hint that maybe we should clean it up. So the reason I've done this is so that I can reuse some logic here. And what I'm going to do is I'm actually going to refactor first. So let's call this method register default copy. It's not the default copy, only the library knows if it's a default copy. Register copy. Okay. And let's make some of these fields. So we're going to repeat what we did, the pattern for, and so also for the email alert. So repeat the pattern that we used in the first test. Thank you. Let's check that that's working. Okay, so we now have the ability to turn this into a setup that we can reuse. So let's import that, get rid of that. Should all still work, it's all effectively the same test. So now our second test should be much easier to write. It's simply that we're going to verify that it tells the email alert to send itself, for want of a better language. So let's verify that our email alert, which is a mock object, that's whether the method in the madness was, is sent. Okay. I think we actually need to tell it the title, don't we? Okay, so let's import the verify. Verify. And let's add the send method. So we're working backwards from the verify. When we run this, it ought to fail because that interaction isn't happening. Wanted but not invoked, and that is easily fixed in Title by simply, once we've registered our copy, telling the email alert to send, and the information we need is the actual title itself. So let's assign you to a field. That's that sorted. So our test is passing. Our test code is relatively duplication free and hopefully easy to understand. So now that we've got title working the way we want it, we're leaving email alert alone because there's, as I said, it's a can of worms behind that interface and we're going to figure it out later, but we've got a placeholder for it now. So we're faking it until we make it. And there's one last piece of this whole jigsaw, which is member. So library tells member to award himself priority points. So we're going to move on to an implementation of member just to finish up. So let's create a unit test for member and let's call it member tests so that it's obvious what these are the tests for. So member has a responsibility. It doesn't tell any other objects to do anything. So its responsibility is to awards itself priority points. Okay, what did I do that for? I'm so butterfingers today. It's because it's the 6th birthday. You see, that's what it is. So what we're saying is a member who has no priority points, if we award them 10 priority points, then it will have 10 priority points at the end. Get priority points, priority count. So let's fix these one at a time. Create the local variable member. We don't need to worry about mocks or collaborators or any of that stuff because we're at the innermost object now. So this is just good old-fashioned state-based testing. That's an integer, thank you. And let's initialize member. It's just a new member. Has no collaborators, no need to dependency inject anything into its constructor, for example. And now let's award priority. I might just change that later to award 10. Award yourself 10 priority points. This will fail because at the moment it doesn't do anything. So let's run it and see. Yeah, it doesn't do anything, and we should be getting 10 and we're getting 0. So very, very easy to pass this one. And Again, we could triangulate it and just hard code a return value of 10 and like that. But I think, to be honest, this is so trivial that I'm just going to implement it in one step. So let's make that field. Okay. Priority points. And we'll add the points to it. Let's just be explicit and initialize it to 0. So we run that, it should work, and permission to clean up. Let's just check we haven't broken anything. Lovely. So there you have it, basically. There's an end-to-end implementation with a placeholder for a can of worms that I don't particularly want to open yet. That we believe once that can of worms has been taken care of, once we've figured out how we're sending email alerts, should pass the acceptance test. Now, I just want to stress this again. The ultimate arbiter of whether or not this design works is whether or not it passes the test. So you've got to keep running that acceptance test to make sure that it does. And you're not done until that test passes, basically. Now, there is a school of thought that says, look, do we need to write all these assertion-based tests? Could we not just have them in the acceptance test and then write interaction tests internally? There's an argument for doing that, and some people are very successful doing it that way. My own preference is to have the tests as close to where the work is done as possible, and to have tests that only really have one reason to fail. So it's much easier to pinpoint when a test fails exactly what's gone wrong and where. So if you're doing this kind of end-to-end OO TDD style stuff, my preference and my recommendation would be to break it down and test individual responsibilities at the point at which the work is done, where the work is done in the design, rather than relying on potentially slow-running and cumbersome front-end tests. There is another argument that suggests very strongly that an acceptance test is a test that the customer executes themselves. That you can automate the logic of an acceptance test, but then it's not an acceptance test. It's only accepted when the customer has seen it work. So there's that aspect to it as well. And then there's the old test pyramid, the testing pyramid, where for performance reasons and cost reasons, it's preferential to rely more on internal developer tests, unit tests like these, than it is to rely on front-end heavyweight sort of GUI tests or controller tests or integration tests. And so you build up a sort of pyramid where you might have a few automated acceptance tests, but most of the logic is actually modeled, if you like, captured in internal tests. Now, I prefer that approach because you end up with a suite of unit tests that can be run very quickly and that ask all the same questions, but they ask them closer to where the work is being done. But again, just to finally stress, the ultimate test of whether or not this is a good design is whether or not it passes the acceptance test. So you always have to come back to that. Okay, so that's sort of end-to-end test-driven development, following on from that blog post. I hope it's made some kind of sense. I hope it hasn't been too long and too cumbersome. So there'll be another screencast to celebrate 6 years of Codemanship next week, if time allows, hopefully. We'll try and find something a little different to talk about. Okay, well, thanks very much.